For example number 6 out of our text, we are given the function 1,000 times the quantity 1.0525 raised to the t equals 2,500. And I suppose I could probably read the whole thing. This is an interest problem. Sarah invests $1,000 into her account that earns 5.5 or 5.25 interest, and it's compounded annually. How long will it take to reach 2,500? So this is where we're applying this property. The initial investment times the quantity 1 plus r, where r is the interest rate, right? Raised to the t, where t is the time, and then that's all a function of time. So in other words, how much time will it be till I get a certain amount of money? So she invests $1,000, all right, and so the original investment is $1,000, so that's where the 1 comes in here, right? We can't forget about the original amount, but then we're going to add to that the interest rate, which is 5.25, right? And so if we're going to add the 5.25, that's 1 plus 0.0525, right? 1.0525. I always say it wrong, but I write it down right. All right. And then we're going to raise that to the number of years that we're going to calculate the interest. So every year we're going to tack on this 5.25% to the original amount, and then plus the interest. So that's how we frame that. And what the question in the textbook is asking us is, when will she have $2,500 in her account? So the first thing I want to do is clean this up a little bit algebraically. I'm going to eventually hit this with e to the, well, I'm going to raise everything as a power of e. So before I do that though, I want to kind of move this 1,000 over. So then that leaves me with a nice clean 1.0525 raised to the t is equal to 2.5. Okay, and so now that it's like that, if I raise everything to the e, or I'm sorry, make everything a power of e, I've got this really nice property that I could take advantage of. Oh wait, not raise it to the e. I'm so silly. I need to take the natural log. Now the reason I want to take the natural log of this stuff is because there's a property in logs, and I don't know if you remember this or not, that lets me take this t and toss it to the front. Okay, so when I toss that t to the front, I'm going to say t times the natural log of this stuff. Okay, and so that's equal to the natural log of 2.5. Okay. Well, since t is being multiplied by all this stuff, if I divide both sides by the natural log of 1.0525, then I'm going to get the natural log of 2.5 all over the natural log of 1.0525. Now remember, these are numbers. When you take the natural log of these numbers, it's actually literally a number. So I'm going to plug those into my calculator, and you could do it all in one step if you want to. So I'm going to say the natural log of 2.5, close my parentheses, divided by the natural log of 1.0525, close my parentheses, hit enter, and I've got 17.9 roughly, if I round that. And so what does that 17.9 mean? Well, what it means is it will take 17.9 years for $1,000 at an interest rate of 5.25% to become $2,500. Any questions?